Range is sum of BST. Given the root node of binary search tree and two integers, low and high, return the sum of values of all nodes with a value inclusive range low, comma high. They have given us a binary search tree, which is a perfect binary search tree. That means it has a left root dot left and it has right node as well. And the if I tell you the definition of this particular binary search tree is that left is always less than the root dot value and right is always high than the root dot value. This is like a definition or um, it's binary search tree, right? It's like a particular it's like a particular definition of perfect binary search tree that always left root nodes are less than root dot value and right root nodes are always higher than that of the root dot value. This particular definition we can be using in our particular in our sum. Let's start this approach. So the first approach is, if you see this binary search tree, you have 10 as the root node. And if you see the input which they have given us, they have given us this tree, and then they have given some range, that is low is 7 and high is 15. What they are asking, that between this particular range we have to find out the nodes and add and give them there, that sum of those nodes. For example, let's take this particular example itself. So if you see, the root dot value is 10, right? Root dot value is 10, which is between the range of 7 and 15. That's why we are going to take 10 and then check next node. Let's go to the left. In the left, root dot left, the value is 5. Is 5 in between 7 and 15? No, 5 is not between 7 and 15. Let's check, let's go further to the left. Here in the further left, we have number 3. Is 3 between 7 and 15? No, 3 is not between 7 and 15. Now let's come back to the root and then go to its right. In the right, we see 7, which is between the range of 7 and 15. And let's take that number. Now again, go back to the root and then traverse it to 15. Is 15 in our range? Yes, 15 is in our range. So just add that 15. Next, again go to root dot right and we see 18. Is 18 in our range? No, 18 is not in our range. So we are not going to take that 18. And we are just simply adding 10 plus 7 plus 15, which is going to give you the answer of 32. And we are going to return that as an answer. This is what we are supposed to be doing for this particular sum, because they have asked us find out the nodes which are between this low and high range and give us the sum. That is what is the question all about. Now let's try to find out how to solve this particular question. So if you see whatever I have shown you right now, I was repeating some of the steps. If you would have observed carefully, like they have given us a range of 7 and 15, right? So I'm checking this root dot value. Is it between 7 and 15? I'm going to the left side, checking that root dot left value. Is it between 7 and 15? Again I'm checking here, again I'm checking here, again I'm checking here, again I'm checking here. So all these nodes I am using this particular range and checking each nodes. So I'm using a recursive call and I'm using a depth first search over here to do this particular action. I'm using depth first search to do this checking action at each particular node. So if you observe every node, I'm using the DFS method, right? Every node I'm using DFS method. What if there are a lot of nodes in this tree node? For example, let me give you this example. Here it is 10. Then they have given us 5, they have given us 3, they have given us 7. Then we have 1, then we have 0. Again down we have 1, then we have 0. Again we have down over here. Again, here it is 15, 18, then 22, then 24, all these numbers are there. Then what will happen if we have such kind of a tree? What will happen? We will have to do the depth first search, checking on each particular node, right? We are going to check every node, whether it is between 7 and 15 or not, which is going to take more time complexity when it runs this particular this particular algorithm. When checking each node for depth first search is going to take a longer period of time. To avoid this situation, we can use the definition which I told you at the first. The definition of binary search tree, that all the left side is less than the root dot value and all the right side is greater than root dot value. So how can we use this definition to solve this particular problem? So if you carefully observe it, we have to find something between 7 and 15, right? And we know that left is always less than root dot value. So what is the value of root? 10. 10 is the root value, right? So 10 is between the range of 7 and 15. We used depth first search over here, right? We used the depth first search over here and found out that 10 is between 7 and 15. Now ask the here itself, should I go to 5 or not? Should I go to left or not? Because left is always less and our less value is 7. So we should actually check whether 7 is there in 5 or not, whether 7 is there in left or not. So we are going to 5 and we are going to left and checking the value. It is 5. So 5 is not in the range of 7 and 15. Do you think that we should further go to this particular node? No need, right? No need, because it's the left is always going to be less than root dot value. That's the definition. So no need of solving depth first search over here and checking whether it is that node is between 7 and 15. We don't need to do any depth first search for this particular node, because we know that the number of root dot left will be less than 5, which will be less than this particular root dot value, because left is always less than root dot value. Next, should we go ahead and check in the right side? Yes, we have to check because it's 5, right? And we have the number 7, which is greater. And thus we find out that there is a node which is between range of 7 and 15. So we did a depth first search over here and check whether that node is between that range or not. Let's go towards the right side. As we know that 15 is in our range, so we did a depth first search here to check it. Is it necessary to go ahead of 15? Because endpoint is 15 itself, right? The range, high range is 15 itself. So no use of going again at the extreme right side, because we know right is always having higher nodes than root dot value. So this we don't have to traverse itself. So we just did a depth first search only on these particular nodes and find out our answer, right? We just did the depth first search on these particular nodes and find out the answer. We didn't use these nodes. We have not traversed. This will help to solve the problem and thus decrease the time complexity when the algorithm is running, and thus the space complexity is also often and time complexity is also often, just by using the definition of binary search tree. Of course, we are using depth first search everywhere, but we are using that depth first search only to those nodes where root dot where it is in that particular range, right? And we know that by definition root dot left is always less than root dot value and root dot right is always greater than root dot value. With that particular definition in mind, we can solve this problem very easily, and time complexity is O of n and space is also O of n. Let's define over here the variable, that is the sum variable, just in case we need this because we have to return the sum. Let's define our tree node. Whatever I told you the definition, that I'm going to define it, because That's a very important definition for this particular sum. So I'm going to define that. So I'm creating a class tree node, and this class consists of value. It consists of tree node left and tree node right. These are main parts of the tree node. And then we have to initialize this class by creating the constructor of each, because we are using this particular we are going to use the value, we are going to use left and right tree nodes, so we have to initialize them, and this is a default constructor which I'm creating. Now I will be creating another constructor which has a value as an argument, this dot value equal to val, and then I'm creating another constructor to initialize my right and left tree nodes. Tree node left, tree node right. This dot left equal to left, and this dot right equal to right. Just initializing the tree nodes. Now this is just the initialization of this particular tree. So this thing, if you do it in the interview, they will understand that you know the concept of the tree node, but it's not a mandatory thing to do it. Next, let's start the algorithm. Public and range sum of BST, right? Range sum of BST, and they have given us tree node root. They have given us a root, and they have given us the range of low and high. Fine. Now I'm initializing sum to be at 0. I'm using a depth first search as shown in the diagram. For depth first search, we require root. We require the range, that is low comma high. And what we are going to return, we are going to return the sum. Let's define our depth first search. So what is the depth first search? We have to define it. DFS tree node root include int I. So first thing first, if root node is null, if root equal to null, then we are just returning back. We are not going to do anything. If null, we cannot compare also, right? So we are not going to do anything if that's the case. Otherwise, we are checking if low is less than equal to root dot val and high is greater than equal to root dot val. If this condition satisfy, then only I'm going to add in my sum. Otherwise, I'm not going to add in my sum, as I explained you in the diagram, that I'm going to check between that particular range. If it's there, then I'm going to add it. If it's not in that particular sum, then we are not going to add in our sum. Simple. Also, we are checking, we are then going ahead, right? But when we are going ahead, we are checking if low is less than root dot val, then only go and do the DFS over there, where in the left side. Because if low is less than root dot value, then only we have to check the DFS method at root dot left, as shown in the diagram or as I have explained you earlier. We can do that only and only when our left value is less than that particular root dot value and it is in our range that we are checking it. Low is my range, right? Low is my range. That's the reason we are checking it. If this is not the case, then we have to check at right side. If that is not the case, then I will be checking that whether my range is at the right or not. And same thing, I will be adding in my sum only when I meet this particular condition, when that root dot value is in particular in that particular range, then only I will add it into the sum and I will return it. So depth first search, I will be doing it only and only in this particular condition. I'm not doing DFS everywhere in each node. Only if this node, if this low is less than root dot value, I can also write one more thing just to clarify you that if high is greater than root dot value, then only we are going to do this particular depth first search. Otherwise, we are not going to do this depth first search. We are just checking these two conditions and trying to do the DFS. Time complexity is O of n. We go of n, and space is also we go of n. Thank you for watching.